Hi, Vijay sir.
Good afternoon, ma'am. Good afternoon.
Hello, how are you?
Uh, Fine, ma'am. Fine, ma'am. Am I audible, ma'am?
Yes, yes, you are very well audible. Shall we start?
Yeah, ma'am. Please. Please.
Okay. So, thank you, Vijay sir, for accepting the invitation. A very good afternoon to all the participants, and welcome to the last session of fifth day of the workshop of the QIP STC. We have with us Dr. Vijay Bhaskar Semwal. He is currently working as assistant professor at NIT Bhopal. Before joining NIT Bhopal, he has worked with NIT Rourkela, IIIT Dharwad, and also NIT Jamshedpur. He has earned his doctoral degree in robotics from IIIT Allahabad in the year 2017. He did his MTech from IIIT Allahabad itself and BTech from College of Engineering, Roorkee. His areas of research are bipedal robotics, gait analysis and synthesis, the same topic on which he is going to talk today, artificial intelligence, machine learning, and theoretical computer science. He has published more than 15 SCI research papers. He has received early career research award by DST SERB and the Government of India. His research areas are algorithm perspective of machine learning, AI, deep learning, and bipedal robotics. He has delivered more than 35 talks. Currently, he is working on human health monitoring using gait pattern, human activity recognition, and reconstruction of impaired gait. Thank you so much, Vijay sir, for accepting the invitation and coming here for the workshop for this session. Thank you so much.
So thank you, madam. Thank you for such a nice introduction, and thank you for opportunity also. So good afternoon to all the participants. And madam, my screen is visible.
Yes, it is visible.
Yeah.
You
Okay.
can go
Okay.
ahead now.
So what I will do, I will divide my talk into part. First talk, I will give you introduction of what is human gait or human walking. Gait is the walking pattern. A little bit how you can utilize for human health monitoring of human, how you can utilize human walking for human health monitoring. So it is as a IoT application which I will present here. The second portion of talk in which I will cover how you can use TinyML, that is compressed machine learning model, that is especially used for microcontroller when you are running the code over microcontroller and you have very limited memory powers. And the benefits of edge computing also you can see. So second portion I will cover how you can compress the deep learning model, infuse the code over microcontroller, and how you can utilize for human working activity recognition. The first coming on the first portion, how you can utilize human walking for human health monitoring. So first, let us define what is locomotion. Okay, so you can see that this picture is here, and the human structure is bipedal. We have two legs, left leg and right leg. So it is by nature it is bipedal. We have two limbs. With the coordination of left and right leg, we used to walk in the forward direction. Okay. You will also observe that this is one complete gait cycle of one healthy person. Different people has different walking style. If it is elderly subjects, its walking pattern will be more compared to the healthy subjects. And if it is athletes, or they will have more better walking cycle. From diagram, you can see also that both the each times your one foot is always in the contact of ground. You can see from here there is left foot and right foot. Both are coming on the ground alternatively. Once it is touching the ground, that is called heel contact. Okay. Another is toe off when it is coming in the air. So the foot which is in the air considered as a swing phase, and the foot which is touching on the ground is called as stance phase. You can see that left stance phase 40%, left swing phase 40%, left stance phase 60%, and for similarly right stance phase 60% and swing phase. That means the swing phase is consisting of 60% of and 40% of entire gait cycle, and stance phase will consist of 60%. Now, why the objective we need to know why we are going to study these human walking patterns and where we can apply. So the first objective that we can monitor the human health because the walking pattern is severely affected by the various diseases like Parkinson's, paralysis, or your mental status, your toughness, as well as your um, energy level also depending. Okay, and the human walking is very sophisticated as well as it is very good gift of gods which they have given, And due to this, we used to perform different sort of walk, like slow walk, fast walk, running with a fraction of second. We can change from one mode to another mode. Apart from there, we have two limbs. That's why it is bipedal. And the motivation is that we can if there is any obstacle, okay, if any canal, we can jump over there. We can negotiate easily with the help of legs. Okay, so entire leg walk is represented by the movement of left leg and right leg. And if you further divide this representation of walk, so you will use for hip joints, knee joint, and ankle joint. That means human walk is the manifestation of change the joint angle of left hip, left knee, left ankle, right ankle. All three joints will move, and there is allowable range in which you can move. Okay, due to this only you are able to walk. If suppose you have no knee joints, so you will not perform different sort of walk. You will only performing single sort of walk, either slow walk. You will not able to switch from one. To go in the depth, when one foot is contacted on ground, another foot is in the air. After some time, the situation will change, and the foot which was in the air will come in the ground, and the foot which is in the air in the ground will go in the air. So this is you call switching time. When we are moving from one foot to another, that is you call switching time. So during switching time, you will it will appear like both foot are touching on the ground. This is you call double support phase. So what is happening? There is single support phase, there is double support phase. When both foot are in the ground, is called double support phase. When single foot is on the ground, that is called single support phase. So if you see that in the bottom here, double support phase, single support phase, double support phase, single support. So this double support phase is simply representing you change over from one mode to another. Okay. So initially your both foot are in the ground, you started your journey. Now your one foot is in the air, then it is coming in the right swing phase. Then you are changing your mode. So again you are in double support phase for 2% of time, and then you are going in the left swing phase. Okay. So let us see the actual definition, theoretical definition of human walking or gait, which I will refer most of the time. So human gait refer to the locomotion achieved through the movement of human beings. With the help of left or right leg, whatever motion we are going to achieve, that is referred as a human locomotion. Human gait or walking pattern is defined as bipedal. It has two limbs, left leg and right leg. That's why it is bipedal in nature. Then biphasic. Why it is biphasic? As I already told you, there is swing phase and stance phase. There is swing phase, stance phase. That's why it is biphasic. And further we can subdivide. As you can see that in diagram there is 8 subphases. It is further subdivision of because entire gait cycle is non-linear. We used to represent into small subphases, and this is time series data. This is I think that a healthy person can complete this walking pattern within 1 second. So it is bipedal, and forward population of center. That means we are moving around center of gravity, because we used to check where our center of mass is representing. That is generally near to abdominal. Those male and female has different center of mass. Okay, and we are moving in the forward direction, and in which there is alternative sinus movement. Sinus is your limbs, which is alternatively moving left and right, left, right, of different segment of body with the least expenditure of energy. Human walk is very perfectly designed. It is taking very least energy. You know that everything's from the nature, whatever we have received, it is very optimized. If you see that when we are writing in the whiteboards, we are always putting with the 90 degree. Okay, if you put straight in the like this hand, you will find maximum energies. Okay, you will get tired easily. You'll get this is in robotics we used to understand it is similar configuration, where you cannot find the inverse of matrix. So you'll go for pseudo inverse other things, but generally such configuration we used to avoid, because there is no as such motor which can generate such a torque which can support this. So I'm not going that path. Just I'm focusing on the walking pattern. So human gait cycle. What is gait cycle? It is walking involve at least one foot in the contact of the ground all the time. When foot is lifted off the ground, the limb is considered as a swing phase. When the foot is contact with the ground, the limb is considered as a stance phase. So that's why it is bipedal. Stance phase, swing phase, stance phase. to measure the values, to measure the human health, to monitor the health through IoT device, because nowadays there is various wearable sensors which are non-invasive in nature also, which is not harmful and you don't need to take permission also many times. Okay, so such sensors either you can wear over your body or either through camera also you can capture. Okay, another important parameter is gait velocity. Gait velocity is walking speed. The habitual of walking speed adopted by the person in everyday life. So medical researcher, which I will show after some slide, how medical researcher has found it is of the great interest to explore the gait velocity. Okay, it's very important to understand the human health because your neurological uh, due to the aging, once you will grow the elderly person, your neural cycle will start decaying. Okay, your neurons will start decaying, will start killing. So in this case, what will happen? Your working pattern automatically will get affected because it is related to human neurological systems. Okay, brain also. So walking exercise, when you perform walking exercise, generally doctor used to recommend you to perform walking exercise daily or running if you are healthy, or if you are elderly, then you can perform walking exercise. It involves your nervous system, that means your brain, neural system, cardiovascular, it's related to your heart, pulmonary, it is related to your stomach, and musculoskeletal, muscles along with your bones. Okay, and hematological system, you can find that various places nowadays, such like in the big hospital hematological diagnosis system, and all these processes will involve when you perform the walking, you need to require more and more oxygen. That's why during walking you used to start uh, breathing fast. The reason is that we require more and more oxygen to allow to contact the muscles. Okay, impairment in one of the system, whether your nerve system, cardiovascular, pulmonary, or musculoskeletal system, will lead for temporary or permanent disabilities of your walk. It will affect your walking patterns, so impact the person gait velocities. Okay, that's why researcher has considered. Let us take the gait velocity. If any abnormalities having any changes is coming, will diagnose as. That's why the physician has called gait velocity a better predictor of various health issues. So you can see also if video you can, I can click video for you. What is locomotion? The video is not playing here. So you can see that different subjects, and we have applied different variable sensors. In first two images, I am using that your mobile phone. Okay, which has already enabled IMU sensor, inertia measurement unit sensor, IMU sensor, which has accelerometer plus gyroscope. Both things are there. Accelerometer is giving acceleration around XYZ axis, and gyroscope giving in rotation around XYZ axis. That I will tell once I will discuss the second phase of talk, how we can capture the data through Arduino boards and how you can fuse the code over Arduino Nano BLE Sense, that is microcontroller, which is enabled with some certain sensors. So for this study purpose, we are using IMU sensors. IMU sensor you can place over different body portions. You can put over the heart also to monitor the heart rates. You can put over the different joints to capture the joint angle. You can place, you can capture the joint velocity also. Okay. Another technique that this is now from China, where they are not supplying, but earlier we have this Bluetooth enable IMU sensors. Okay, so we have placed over hip, knee, and ankle, and we have captured the data. Okay, and we have performed different sort of walks, slow walk, brisk walk. We have performed the exercise over treadmill on the different speed, 1 kilometer per hour, 3 kilometer, 5 kilometers, 7 kilometer. We try to assess. We have observed for elderly subjects as well as younger subjects. As you see that human walking, uh, the pattern, it evolved with the age and decay with the age. As the baby used to take almost 2 years to learn the walking, because it involved the coordination of your brain, your body muscles, strength, all sort of things. That's why baby used to take much time to learn. Once you have acquired this behavior, you have captured this behavior, you will simply perform these activities. After some time, as you grow elderly, like 60 or 70, you will again start losing your walking pattern due to the decay of neurological systems, neurons. So that's why it is becoming very important to analyze human health through walking pattern. Now, another important aspects of human walking pattern we can use you can use for biometric identifications. This is physiological biometric identification. You have physical biometric identification like palm, face recognition, iris, and other things. Similarly, you have physiological biometric identification in which you have gait, velocity, and other things. And this study I can use for development of bipedal robots, which can walk very similar to human being. Okay. Another aspect we can use for push recovery capability or for recovery. As nowadays elderly people are very alone at home. So what is happening? They are quite possible that they will face some external forces, or due to the disbalance of the body, they might lose their balance and they will fall on the ground. Okay, and maybe they will get unconscious also. Such can things we can trace through these wearable sensors. We can track their body postures, inclination, the different body joints, and we can decide that whether person is whether person is uh, continuous data of accelerometer data. If person observes some falls, okay, so we'll see that whether person able to sustain over the fall, whether he's able to recover or is still unconscious. Such kind of observation we can make, and we can save the human life also. Okay, or either we can activities like natural speed, slow walk, medium walks, fast walk, walk with the help of tool, walk with the help of hill and stair ascending. And it used to trace the 25 joints 0 to 24. I was interested only for joint number 10, 11. That is hip left, knee left, ankle left, left, hip right, knee right, because I was interested for only lower extremity related working. So now I'm coming on directly on my work. That I'm going to present in the second page of talk, how you can design the tiny ML based models, okay, on this portion of talk. It could be very interesting talk. Okay, so moving toward design of data driven, that means machine learning. All machine learning model you require data. The objective to find some mathematical function which can divide the data or classify the data. And we are using model for human activity recognition using TinyML and deep one. So in this, what I will do, we'll first understand the deep learning, how we are collecting data. Then we'll see that data processing, train, test, validation set. Then we'll build the deep learning model. Then we'll compile and we'll see their accuracy. Then to compress the deep learning model, we'll use model pruning and quantization. And finally, we'll fuse over there. So for this purpose, let us see that what is my objective or introduction. So the machine learning on the microcontroller. The microcontroller has very limited memory as well as power. Okay, so is the most efficient way of doing processing, and the computation is very cheap and relative way of developing edge computing. In edge computing, what is happening? We are not sending data anywhere. The machine itself is sensing the data and processing. And we require very least energy. If you are able to do the machine learning on microcontroller, you are able to achieve this target. For this purpose, I have used Arduino Nano 33 BLE Sense board and microcontroller to capture the 5 gestures: square, jump, walk, run, and other. The board has capabilities such as embedded sensors and BLE sensors. We have built a deep learning model to capture the gestures data, and I've considered the 5 gestures: square, jump, walk, run, and other. And through this BLE sense, and the beauty of this BLE sense, it is enabled with some sensors. You can see that this is what BLE sense, and you can put over impact pocket. The form factor is very important, small. You can put place over. It is hardly like your key or pen drive, not much than this size. Okay, so you see that it is enabled with the various sensors, like you have 9-degree IMU sensors, 9-axis IMU sensors, which has triaxial accelerometer, triaxial gyroscope, and triaxial magnetometer. Then you have proximity, light and gesture sensors, temperature, humidity sensor. Then there is power LED, whether power is coming in not green color. Then micro USB port is also there to connect with your computer systems or mobile phone. Programmable LEDs in the orange color, whether your code is going to fuse or not, that time you have to this one. You have pressure sensors, you have microphone to record your voice, and then ultimately you have Bluetooth module, or the processor is Nordic another 52840 processor with the Bluetooth module, and you have RGB programmable LEDs. So the benefits, the form factor is very important. That 5 into 80 dimension. It has reached 9 onboard sensors. For this research, I have used only accelerometer and gyroscope to design deep learning models. The Nordic NRF522 processor was used, which has 32-bit ARM cortex, and CPU also was there. The static RAM was 256 KB. The flash memory, which we have considered 1 MB, and that is the challenge, that it has very limited memory. And generally, deep learning model, you will see that it will be more than 4 MB or 5 MB. The challenge was that we have to compress the deep learning model over these devices, and still we have to retain the same accuracy or performance. You cannot sacrifice the accuracy. The operating voltage is 3.3 volts, and that is the challenge in the homes. We are getting the supply of 5 volts, so we can use converter. Another challenge which we have faced, faced by us, how to design, how to capture the training data through Arduino boards. For this, we have written the Python script also. Okay, as the Arduino Nano board is, the code was available in the C, which we have captured. Okay, then we have stored in the Excel sheets the Python script to capture the data through BLE. Second challenge, the size of machine learning model is huge, and loading into a microcontroller we require to compress. For this, we have used coding and quantization techniques. The goal which we have to achieve is to showcase the following benefit in developing the edge computing application without sacrificing accuracy on the microcontroller. We have cost effective because we are using very small things. Low energy consumption, the energy should be very less. Data privacy, as we are using, you are not uploading your data over cloud. You are just keeping with the machine is self-processing. So we are ensuring the data privacy. The form factor is very important, small, and flexibilities. The entire workflow of model is you have Arduino boards through which we have captured the IMU data. Then we have built the deep learning models. For this, we have split data into training, testing, and validation sets. Then we have model interference. Okay, and then to see the output, we have LED colors, whether red, green, and blue. It can identify which gesture you are performing. And the infer gesture is based on the probabilities, like softmax function or other function used to return probability distribution. So for each gesture, we are getting probability. So for data collection, we have used three on-board sensors, which are accelerometer, gyroscope, and magnetometer. As already I discussed, accelerometer is recording the acceleration around XYZ axis. Gyroscope is giving rotation around XYZ axis. Accelerometer you can record in the as acceleration meter per second square, but we are recording the G force. The range is -4 to +4 in G, and G is 9.8 meter per second square with little bit slack minus or plus 0.12 mg. Gyroscope will give you rotation per second or degree per second. Okay, its range is -2000 to +2000. Magnetometer range is -400 to +400 micrometers. The sampling frequency which I consider, you can it's choice of you. That means in one sample how much data you are collecting. So the row number of row is we have considered 119 hertz. So in one sample I am considering the 119 rows. Okay. The each gesture is performed 100 times with sampling rate of 119 hertz, and the minimum threshold is 1 point. So I perform the 5 gestures: square, jump, run, walk, and other activity. Each activity is performed 100 times, so each gesture become 5 gestures, so 500 total gestures is there. And the sampling frequency was 119 hertz. That means in one sample I am considering 119 hertz. If you multiply 119 into 100, you will find 11,900. That is for each gestures. We have 11,900 samples. The data transfer through the BLE from board center to the your computer peripheral, because first we'll build the deep learning model over my computer machine. Once it is trained there, then using TensorFlow Lite model, okay, TensorFlow Lite is there by which you can compress the model, and you can also convert into the header file, because Arduino board is generally supporting the C language. So you have to take all data, whatever you have designed in the Arduino board, use there. You require the header files which you can import there. Okay, and then Python script to discover the BLE device and establish the connection with the device and capture the data. All gestures data is set continuously. That means will not break one sample data. That means all the 119 records should set the continuously, and data is sent in the form of strings. Okay, so when I will talk about quantization, there I will truncate some data size so that data should be small size of data. It consumes the less memories. So this is connected. You have programmable LEDs, you have power LEDs green color, programmable LEDs orange color. You can see that in screen you are getting data. This AX, AY, AZ, this is accelerometer data, and this is GX, GZ is gyroscope data. We're continuously then taking these values. Okay, 1, 2, 3 seconds. So accelerometer, accelerometer, gyroscope data is capturing. Finally, to build the deep learning model, the data whatever we have captured for 5 gestures, 11900 samples, we have divided into the portion: training set, test set, and validation set. Training and validation will work purely together to see that whether model is going to overfit or not. To check the model how model is going to fit, that is checked by the validation, and how model has fitted, that is checked by the testing error. Then training and validation, we have prepared our deep learning models on our computer system, which is of huge size. You have seen the performance. What we have achieved, 96 or 97% accuracy for the gesture recognition we have achieved. Then the objective was to fuse over the microcontroller. For this, I need to do pruning and quantization process. Pruning means certain weights which is of least significance. Let us remove such weights, and then not to lose the objective or the desirable things, that not to lose the accuracy. Okay, once it is done, then we'll test again. The model has significantly lost its performance. As earlier I was getting 96, or still I'm getting 96, or more better or lesser. So the data should be, this process should be lossless. Then finally we have model inference. The deep learning model accept input and generate output in the form of tensors. So maybe you heard about like matrix, and there is tensor also. Okay. So as I know that there is 5 gestures, square, run, walk, jump is performed 100 times, so total is 500. And we have sampling frequencies 119, the sampling frequency. And I'm capturing data for 3 for accelerometer, 3 for gyroscope. That means AX, AY is at accelerometer data around XYZ axis, and gyroscope data around GX, Y. So the input tensor size will be 500 cross 716. What is this 716? Because 119 sample for 1 thing and 6 columns was there. So 119 into 6 is 716, and 500 times I have done, that is the tensor size. And the output, we have only 5 categories. You can use one hot encoder, 0, 1, 1, 1, 0, 0, dash 4, 0, 0, 1, dash 3, 0, 0, 0, 1, dash 2, 0, 0, 0. This way I prepare the tensor chart. And for all 500 samples, I am giving these tensor charts as output on hot encoder. The training data, 60% was considered for training, 20% we have divided for testing, and 20% for considered for validation purpose. Then the deep learning model which we have considered, simply you can consider neural network model also. We have considered total 7 layers, in which you have 4 dense layers and 3 dropout layers. Dropout layer not to overfit the model, so that model cannot get overfitted. And the input layer, you have tensor size, that is 706. Okay, 716, and 500 time I will kept this data as input. The first layer you will have 100 neurons, then you have dropout with the 15%. Okay, 15% neuron you are going to drop out. Then another layer you have 75 neurons, and then 15% dropout. Then again 75 neuron, 15% dropout. Then you have output layer where you are using softmax function. You have only 5 outputs. So first output is 1, rest 4 is 0, second output 0, 1, rest. This is one hot encoding representation. Okay. Number of parameter which we have used 85,155, and the ReLU function was used output of indirectly if the positive and 0. So ReLU is rectifier linear unit. Okay, that is also like piecewise linear function you can consider. If value is greater than 0, you are going for linear function. If value is less than 0, you are going to make it 0. Fitting the compiling the model or preparing the model, we have used optimizer, ADA. You can go from ADA guard, ADA boost, or RMS stroke and other. The fixed learning rate was used. This is 0.001. Those you can go for adaptive learning rate also. The mean square error function was used, and these are simple parameters. Every deep learning model we are preparing this one. You can go for cross entropy and other. Accuracy was the major. Okay, reduce LOR on the PLT used to call back to reduce the learning rate. When matrix size stops improving, that means convergence was not done yet, but matrix size not performing better, so we have used reduce LOR on LR on PLT. The PLT is somewhere a region in the optimizing where you are getting continuously same output for 3 or 4 iterations. So your model is not improving at all, so then you can reduce. Now, the objective was to fuse this data over microcontroller so that you can support the edge computing benefits. To support the edge computing, I'm reducing the my size of model. That was the objective, and with the view of not to lose too much accuracy. So for this, pruning is done, in which we have removed the least significant weight, which is not much important. So for this, we can reduce the weights. And what was the uh, benefits? We are reducing the model size. It make the faster execution and reduce power. Okay. So pruning is a iterative process on the trend model that trim insignificant weight by setting those weight to the zero until specific targets and remove unnecessary connection between the layers. Okay, in dropout, what I am doing, I'm dropping certain neurons. Here I will drop also neuron, but I'm dropping the weight matrix also, weight which is least significant. The quantization is another process, or it is process of doing reducing the model size. In this case, what is happening? We are converting the data size like float 32 to integer 8. So those we are losing the precision. We are not bothered for precision. Okay. So quantization is a process of transforming machine learning model into an equivalent representation that uses parameter and computation with a lower precision. If float 38 is taking 64-bit, integer 8 taking only 16 bits. Obviously, if you are representing 64-bit into 18-bit, you are losing or getting. It's the process where the weight are covered to the lower precision types such as float 8 to 38. So how it works? Take only the range used by the float 32. First, we are considering the range of float 32, okay, which is coming minus 3 into 10 raised to power minus 38 to plus 3 into 10. That is whose complementary representation. Now I know that integer is taking 8 bits, okay, or 4 bits, or the range which is to cover minus 27 because this is signed integer, okay. So I need to convert this float into there. So there is min max and max value. So require an histogram distribution of value in the particular tensor by grouping data into 255 bins. Okay. Because the range is minus 127 to plus 27, so the value will come between 0 to 250. Right. Okay. Moving ahead, this is what is happening. Okay. So now model inference. I will see the what output you will get. As I told that there is LED color. Based on LED color, you have to check which castle you are performing. So board is programmed to use 10 TensorFlow Lite. Okay. To classify guesses, static tensor is there. So the probability you will get, like we have 5 guesses: square, jump, walk, run, and other activity. The color is given red, magenta, blue, green, and white. Okay. So as I am performing particular guesses, I am getting 0.984 probability. See that I'm directly coming out results. This I am not going to discuss how we are getting. The accuracy is there. So initially my size was 2.1 MB. After pruning and quantization, it has reduced to 0.5 MB. And as I know that Arduino Nano BLE sense, the size is 1 MB, it can accommodate. So I have only 1.2, and still accuracy is 96. We have achieved. So now the girl is performing particular gestures. You can see that this LED or this Arduino Nano BLE sense is there. You can see the color, what color it is going to perform. So now she is performing the square. The color is coming red. Okay, you can see like this. Again, I am coming here. Regular gesture she is performing. The yellow light is turning to the red, magenta. Now she is performing jumping. The color is taking. Then I can see. We just focus in the that rounded area. It is giving this blue color. Then now she is performing walking. It is giving perfectly blue color. Now she will start jumping, running. It is giving green. So with this, I will conclude my talk here. And here we started with the gate analysis. We see the importance of leg length, number of legs, how it is important to measure the human health, how IoT application can be designed, how different cognitive aspects and other things also can deal. Okay, how a smart health monitoring system can be utilized with the help of. Then we have seen that second was different health activity recognition or working activity related things in which we have covered five cases. How we can support the edge computing the data. So this is also how simple and efficient it is achieved and design a deep learning model to predict the human gesture to show the benefit of microcontroller. Okay, so we have very fine uniform factors. To the code and other things I will say. So with this, I will finish my talk and I will open the forum for question answering. If you have any question, please feel free to ask the question. I'll be happy to answer. So this is all about my work, which I was supposed to deliver here today. So if you have any questions, you please ask the question. That is all about
Questions?
what I was. So,
Any questions from the participants? Anything that you would like to ask from sir? You can either unmute your mic or you can put it on the chat box. So it seems that there are no further questions. Thank you so much for the wonderful session. Thank you, sir. And you really expressed a lot of things regarding the gate analysis, which was quite useful. And those people who are looking into research into robotics can definitely gain a lot of advantage from this. Thank you so much, sir. Thank you. Thank you.
thank you, ma'am. Thank you,
So
ma'am.
thank you all the participants for joining me for the last session of the day, and we'll meet again tomorrow. The next at 9 o'clock. Tomorrow is the last day for the workshop, and we'll meet at 9 o'clock tomorrow. Thank you so much, everyone. Thank you, Vijay sir, and thank you all the participants. I'm closing the meeting now.